Hello everyone, today is part 2 of the PIR LED project. It's been quite a while since the last video in this. Part 1 was a few months ago. Summertime came, and because of that it actually doesn't get as dark in this room, but now that we're on the declining edge of sunlight, it is going to be important again to get this project done so that there's some light just enough that we can see our way through this room in the pitch black. It really sucks to stub your toes on an office chair when you're not expecting it. And I do have the little schematic here that I did up. We're going to be removing this section here completely because the PIR module that I have actually has a connection for an LDR on it, which means that all of this is superfluous. I can just solder an LDR right onto the PIR sensor. And I have modified this slightly. The output pin of the PIR module doesn't put out enough voltage to actually fully trigger a quadruple 2A transistor. So in order to solve that, what I've got to do is run the output into a transistor and then have that transistor trigger the transistor that triggers the LEDs. I didn't see it really affect the power draw much. When the LEDs were lit up, it's still about 40 milliamps, which is what I wanted because that's roughly the maximum that our little LT1073 is going to be able to put out in this configuration. I have been having some difficulty running these LEDs off of this circuit, but I've determined that the majority of the issue that I'm having is the breadboard that I'm using for it. The connections are very poor, so what's happening is small fluctuations or anything bumping it is causing the power delivery to cut out, and that's causing the LEDs to run really low. I'm planning on putting those into a proper perf board eventually here, and that should make a huge difference. So we're going to be focusing on this half of the circuit right here, the LEDs. I've also removed these resistors here, and I've removed this potentiometer because the voltage drop I'm getting makes these superfluous. They really don't have any purpose at all anymore. I'm using red LEDs right now instead of the orange ones because the red LEDs are working much better. The red LEDs work much better in here just because they have a better forward voltage for pairing them up like this. So yeah, let's start putting this together, and I'll hopefully show you some of the issues I was having, demonstrate them to you. So the first thing I did was I set up two LEDs. And these LEDs are set up so that the large pin is on the right and the short pin is on the left. Now to power the circuit, I'm going to be using one of these little breadboard power supplies set to 5 volts. And that's just because it gives out a very nice consistent power. It gives out exactly the same voltage as my other little LT1073 circuit, but this one gives out much higher amperage, so there's less chance of it failing due to not enough power. So we've got the two LEDs there. We're going to hook up one LED. Actually, we're going to hook up both of these LEDs with a little jumper wire. So when prototyping, I tend to use these jumper wires, and they're really not as good as the actual hookup wire. These wires are very unreliable, I've noticed. So ideally I would be using hookup wire, but I'm not. So I'll just make do with what I have temporarily. So this is the PIR module, and you can see here on the PIR module there is an actual CDS sensor spot, and that's the LDR. If I hook one up there, it'll do all of that light sensing itself, and I don't need to use separate circuitry for that. It's all built in. On here there's also a jumper that sets the retrigger. So when this is set how it is right now, it allows the PIR sensor to retrigger when there's more motion. Otherwise it only triggers once and then waits for the scene to change again. So for what I'm using it for, we want it to stay triggered whenever somebody's moving in the room. So we have to make sure that this is set to retrigger. So we have ground, VCC, and output. So what we need next is the transistor. I'll show you the issue I had with just having one transistor. Power coming into the LEDs, then from the LEDs it's coming through this jumper to the collector of the transistor. Then we're going to have the emitter hooked to ground. And what this is going to let happen is when the base of this transistor is triggered, the current is going to be able to flow through these LEDs, through the transistor, and down to ground. And in order to trigger these, we're going to use this PIR module. The unfortunate thing with this PIR module is its output is extremely small. Theoretically, when we turn this on, I probably messed something up. Ah, yes. I hooked up to the ECC of that to the wrong pin. There we go. So you can see the LEDs trigger. It can be difficult at times to actually get them to trigger. PIR sensor requires quite a bit of movement. It needs quite a big change in order to trigger. So that's what my hand is doing here. Okay, but those LEDs light up, but they're fairly dim. They look a lot brighter on the camera than they do in person. So what we can do is check and see what the actual amperage that's going through them right now is. Just pull this out a little bit. Slide some stuff around. Bring in this, which is the DMO2 meter. And the only reason I'm using this one instead of my normal Proster meter is because the battery's dead in the Proster meter and, well, I just don't feel like changing it out. So this is what we'll have to make do with. So what we're going to do is we're going to take this connection, hook it up to the multimeter. You can see with nothing running through, of course, it's 0 milliamps. I think we can go down to the microamps. So when the light isn't triggered, it's drawing 0 amps, even in the microamp range. But once we come here to the milliamps and we trigger the trigger here, you can see it's drawing 4.0 milliamps, which isn't very much at all. It explains why these LEDs are so dim. And the reason for that is just the very tiny amount of current that can flow from the output of the PIR sensor into the base of the transistor. And we can also check that. You can see here it's 259 microamps coming out of this. And because of that, it doesn't have enough power to fully trigger this transistor. So what I plan on doing, and what I'm going to show next, is that we can hook up this transistor here to a second transistor, and that transistor can trigger the LEDs because there'll be more current able to flow through the transistor than there is through this output. It's just a really simple amplifier, I suppose, without using any other components other than transistors. So this transistor gets hooked up exactly the same, almost exactly the same. We get the power in, and then the power out of this one now goes to the base of the original one, and the output of the PIR comes into the base of this one. And look at that, it's already working because I already triggered it by accident. Wait for it to turn off. There we go. So you can already tell those are exponentially brighter than they were before. So that means there is certainly more current flowing through. Of course, to verify that, we're not just going to guess by saying, hey, it looks like it's drawing more. We're going to actually test it with the multimeter. So of course, in the final design, we're also going to have 4 LEDs, not just 2 LEDs. So this is still just a mock-up design. Now what we're going to do is we're going to test the total power draw. So through here, into here. So we have 40 milliamps triggering in here whenever I activate the PIR. That is basically the exact threshold that we want to be at. We don't want to be much higher than 40. I believe the circuit that I built for the power can actually go up to 60 milliamps if I'm lucky. But 40 is more than enough to make these LEDs bright enough to see in the dark. And what we can do now is we can also add in the other two LEDs and just check and see how much power that adds to the total. So yeah, adding those extra two LEDs only added about 5 milliamps, which is perfect. That's ideal. That means that it's not going to draw too much extra. This probably isn't reading the total circuit power. And that's because where we're hooked up, it's only going through the LEDs, and then it will be leaving through this transistor. It's not actually coming through all of the other circuitry. So that's another thing that I have to test and figure out, is how much the total power draw of everything here is. I think the easiest way to test and see what the total power draw is going to be is actually going to be to remove my little breadboard power supply from that board, attach it to this board. Then we're going to connect the multimeter just as it is, but we're going to move its jumpers so that it is just bridging everything here, so that it is delivering the power from the board over here to the board over there. It's fairly difficult to trigger this because I have to reach halfway across my bench here to kind of get in the range and then keep moving, otherwise it can't see it and then it goes out because it's pointed kind of down. But you can see it's actually still drawing 45 milliamps. We knew that this was drawing 250 microamps, and these transistors really, they don't draw basically anything. They have a bit of voltage drop, forward voltage drop, but other than that, they really don't consume much power. I think it's something like 100 microamps as well. So if it's 45 milliamps, that's going to be pretty epic runtime off of a D-cell battery or two C-cell batteries. So the quiescent current here is very low, 142 microamps, 143. So it should be interesting to see how long this will last. I'll have to do up the calculations on it, but I'm pretty sure it's going to be in the number of years for a single D cell. So the advantage to the C cells, if I run with two C cells instead of a single D cell, is that I get almost double the output current from the LTC1073, which means I could actually up this to a second or third bank of LEDs, giving me 8 or 12 or however many extra LEDs I want, because this seems to be pretty darn power efficient, and that might make it just a little bit easier to see. The downside, of course, is that it's going to draw more power. Now that little LTC chip also draws very little power, so I'm really looking forward to actually hooking that up as well and just seeing what the total complete power draw of this whole system is going to be once I have it set up. So anyway, that is part 2 of the PIR project. Now, I did have somebody in the comments of the last video that I made, the 555 part 3, ask if I could do a video on the DSO138 newbie beginner guide, and yes, I will be doing that. I'm not sure when. I'm thinking that that might be next Thursday's video. That will be the first video that I will have scheduled ahead of time because I'm going away on vacation. But I still need to play around with the DSO a bit. I'm still having a bugger of a time trying to get it to actually trigger properly. It just does not want to cooperate with me, despite doing everything that I've been told and everything the manual says to do. But I'm sure I will figure it out. I hope you found this episode of Tinkering with Terrius interesting or helpful in some way. If you did, then please consider giving it a like, and of course share it with your friends. If you have any questions or comments, be sure to leave them in the section below. Otherwise, you can email them to me at tinkering.with.terrius@gmail.com, or you can tweet them to me at tinkerwterrius. If you haven't already, then be sure to subscribe to my channel. Every subscriber helps, and I make these videos for you guys, so it's very encouraging to see these subscribers popping up. Thank you for watching. I hope you have a wonderful day.